Hello, everyone, and welcome to today's session where we will be discussing lead code as question 49 group anagrams. So, this is a medium level question, and I will be demonstrating a medium question for the first time here today. So, let's dive in together. So, given an array of strings strs, group the anagram together, you can return the answer in any order. So that is what the question is saying, that we have words here in the string strs, and we have to group these anagrams together and give them as a group string. So the thing is, what is an anagram? An anagram is a word which has the same alphabets being utilized in one way or another. Something like this, as an example, we have NAT and TAN. All of them are here and they have the same letters. So one of the ways that we can look at this problem is by understanding this concept. If I were to dive into this task, the first approach that could be taken is to understand how the algorithm would think. One of the ways that we can do is we can sort each of these strings. So something like, then each of them would then look something like AET, AET, and then this would also be AET, and use the sorted string as a key in a dictionary. So what would happen is I would have 1A, 1E, and 1T as my key, and over here I would have, and then I can pull these from the string strs as a result. So then I would get EAT, TEA, and ATE, and this will become my result. So in order to achieve this, the way we can approach the problem is first defining a dictionary. And the way we do dictionaries is by using curly braces in Python. But for the sake of avoiding edge cases, what we will do is we will use the function default dictionary. And the way we'll do it is by using default dictionary. And we want to return these values as a list. So that is why I'll also mention that this dictionary is going to be a list. Then for my s in strs, so this for loop will basically go for one string at a time, and each string, what I want to do is I want to sort them and put them in sorted s. And what I would want to do here is I'll be sorting each of these. So this would become AET, this would become AET, this would become ANT, things like that. And what I want to do here is I would like to join them by this space. What this does is, let me show you right here. So when I do the sorted, it would come out like, when I do the sorted S on this one, let's take this example. I have this EAT. When I do the sorted S, what ends up happening here is the following. It becomes like this: A, E, and T. And this is not what I want. So hence what I do is I join them using this function, the join function in Python, and I remove these braces. So then it becomes AET, and that would be the sorted S. And what I'll do is I'll save them or store them in the sorted S variable. for further use. Okay, now that we have understood that part, the next thing I would like to do here is add them by checking the key, because remember this sorted value, the AET, is my key for the dictionary results. And I want to append the value of S where this to that place. So what this ends up doing is this part. It identifies the sorted S as the key, and I'm appending these variables over here using this append S. Now what is left here to do is to return the values. However, we want to return them as a list. So this is my list. Let's run it to make sure it is working. Yep. So there is a syntax error right here, and this is supposed to go here. And let's see if we are able to. Yep. There's a syntax error right there. And if we run it now, let's see if it works. Yep, and it works. So the space and runtime complexity of this solution would look something like this. So because we are doing using sorting, the solution has a space-time complexity of n log n, and we are doing it m times, where m is the number of strings in this list. So this would be my time complexity. And for my space complexity, let me just put it here. This would be m times n, that we have to uh, do all of the calculations and run the loop m times on each and every list here, and we have to do it n number of times. So for each variable, n is the number of alphabets in each string, and m is the number of values right here. So these number of strings present. Perfect. So that is one way to do it. However, there is another way to attempt this solution, and let me explain it to you after clearing everything that I've done here. So one of the key ways that we can do is by observing the count of the variables, that is the count of the alphabets that is present. So one of the things about Python is that it allows us to check the values through the ASCII variables, and the way it does that is we can see, like, and I'm just giving hypothetical numbers, we can get a difference of the values of, like, let's say the value of C minus the value of A, and this could give us the alphabet that we're on. So how we would do that is to first see there's an E here, there's an A there, and there's a T there. And any string that has these three alphabets present in them become our result, and we can simply append them to our hash map. And for that, what we would do is the following. Let me just fix this out. So we would define a dictionary the same way we did in the sorting solution. And the first thing we need to do is we need to establish a count. So for my string, so for each string in this in strs, what I would want to do is I would want to get all of the account of each of the variable that is present. So this would essentially give me 26 values on the count, and how I could check what value is present or what alphabet is present, I would do it in the following manner. So for each particular string, so for example, the first one over here, EAT, how I would determine what is present is count C minus or of A. So this would essentially give me for the variable that I'm on right now. So even within the string SEAT, I'd individually go and establish the count. And the way we do it is subtracting from A. So that's the initial start. I forgot in my syntax right here, because this is, we're taking it as a variable, but we're taking this value as a constant. And we would simply add one to it. And once we establish the count, we will simply, based on the count, append S. Sorry. We would simply append S in there, in the results. Now there's a key problem here. My count is also a string. And over here to establish it as a key, we can't establish like variables as or a changing entity such as the count that we've defined over here as our key. So the way we solve that problem is by defining it or by converting it into a tuple, because tuples are immutable, they don't change. And once we've done that, simply a matter of returning the values, and this has to be done within the string, because this has to happen in every for every s. If this for loop was outside, it would just run once for each particular for only one of them, for one of let's say over here for one variable, for one string over here, and it wouldn't do it for the rest. So that's why we I indented it to be a part of the first for loop, so that it could function for each and every one of the strings that we have available. And then once we have gone through all of the strings, the last thing that we need to do is to return the values inside the results, but we need the answers as a list, so we would define it as a list. And now let's run it to make sure it works. Yep, as you can see, it works. And this is a more efficient solution as compared to the one that we did. Because in the entire process, we're just essentially utilizing one extra space. So, and that is the number of variables, the number of strings that are going into the solution. So the time complexity for this one would be m times n, because we're doing this for the length of the string for all the present strings. So m would be the number of strings and n is the number of variables inside the string. And the space complexity for this one would simply be the number of strings that is present. So O of m. Perfect. Thank you so much for watching, everyone, and see you again in the next one.